Good day, everybody, and thanks to Taos and the MDD for this opportunity to make this presentation on the Onto copper gold discovery. Onto is one of the largest porphyry copper gold discoveries in the past several decades, but it's also an exceptionally interesting deposit, and it has some unusual characteristics, as I hope to show you. It's also exceptionally young, which makes it an ideal place to understand the timing and the processes in porphyry copper and high sulphidation epithermal deposit formation. This is a required disclaimer referring to some forward-looking statements I might make and some definitions I'll definitely use when I look at the resources of this deposit. So before I started, I thought I'd provide a few slides to give some context for porphyry copper deposit formation and the relationship between the porphyry copper stocks and the advanced argillic alteration in the overlying lithocap. This figure from Silito in 2010 shows the current model with porphyry copper deposits with the copper mineralization usually contained within quartz vein shell and potassic alteration within and around these small stocks. But it represents a smaller portion of a much larger magmatic hydrothermal system with large crustal batholiths or laccoliths, perhaps, probably in the order of between 50 and perhaps 500 cubic kilometers, progressively crystallizing and fractionating, with these porphyritic stocks then channelizing the late magmatic fluids derived from this chamber during late fractionation. And then one other important point is at these high crustal levels, so typically above 4 kilometers, say, the fluids separate into a hypersaline liquid or a brine and a much larger volume of low density vapor, which generally rises to higher levels, and when it condensates into groundwater, it forms highly acidic fluids that cause what we call advanced argillic alteration, typically in more permeable units. And it's this advanced argillic alteration zone shown here in the sort of red outline that is commonly termed the lithocap, just for reference. So this is looking at it in a little more detail around the porphyry stocks, and this figure just shows the classic metal alteration and vein zonation characteristic of porphyry deposits. As I've mentioned, the metals typically occur within and just around these porphyry stocks associated with potassic alteration and quartz vein stockworks, shown here in this sort of dashed outline. And if we look at the alteration, we see a progression from these alteration types associated with the actual porphyry, from potassic to quartz cericitic and then up to cericitic. And then the lithocap alteration within this area here usually transitions from quartz porphyry through quartz alunite to quartz dicite and then out into quartz kaolinite, shown in this striped yellow pattern. With lower temperatures, typically below around 200 degrees, you get the strong dissociation of acids, in this case probably sulfuric acid, hydrochloric, and even potentially hydrochloric and potentially even hydrofluoric acids that cause a distinctive alteration type called buggy residual quartz or buggy quartz alteration. And this is what is shown in this gray color in the top of the lithocap. And then mineralization in these overlying lithocaps is generally referred to as high sulphidation epithermal mineralization, reflecting the very high sulphidation state of the sulfides with covellite, tetrahedrite, tennantite, covellite, digenite, etc. And it's often concentrated within these buggy residual quartz zones, so in this gray area, or in silicified versions of this alteration. And the other feature that tends to happen is essentially a telescoping, where with progressive thermal decline of these systems and or erosion of the paleosurface, the younger alteration types tend to get superimposed on the older alteration types. And this is what's often referred to, you'll see, is called telescoping, where these high sulphidation system telescopes down onto the porphyry part of the system. That was just a bit of background. It's getting onto the deposit. This is the outline of the contract of work here, shown in red on Sumbawa Island. Also shown is Batu Hijau deposit, which is largely mined out now in western Sumbawa, and also the Alang porphyry deposit. As shown in this inset, Sumbawa is just east of Lombok and Bali and eastern Java. And it's part of the Indonesian Ring of Fire with a series of active volcanoes along, particularly in Java, like Ruang and Merapi. Actually, on the recently erupted Semeru, which is in about this position. And then the manifestation of this recent volcanism in Sumbawa is this 7-kilometer wide Tambura crater shown here, which last erupted in 1815 actually, but at that time caused a global warming event and a year without a summer. Obviously, there's also a lot of local devastation to this area. Also shown here are some of the major faults that may be important in localizing this deposit, and are certainly important in localizing some of these volcanoes. This map shows the outline of the contractor work where we completed the work. It covers about 190 square kilometers, and this is superimposed on topography. And shown here is the eventual outline of the Onto resource, which I'll describe in red, and also the position in yellow here of an early discovery that I'll describe called Humpulao East. And what really attracted us to this area, other than some clear indications of porphyry-related copper-gold mineralization from earlier Aberfoyle work in 95 to about 97, was this very large, extensive lithocap here, shown in this grey stippled pattern, with a lot of quartz alunite and quartz stickite alteration, and also a lot of intense silicification. This is what the Onto area looks like from a helicopter. This looking to the northeast. This is sort of on the northwest side of the deposit, so this is one of our old camps. And in retrospect, some of these white gray patches here are some areas of advanced argillic and argillic alteration, and in retrospect represents a portion of the Onto system exposed where it's been eroded in this valley. So most of the drilling was actually carried out about generally about 1 kilometer to the southwest of here, so on the right-hand side, and you can just see one of the drill sites up here in the jungle. So, you know, it's very rugged topography, all jungle covered. In fact, it's a lot steeper and more rugged than is indicated in this photo. And so all the work, other than the initial work where we had to walk in, was helicopter supported, and all the drilling was helicopter supported. So it's up about 700 meters, and then the very top of this photograph on the very highest part would be up to about 1,000 meters. And so to the exploration, we took a fairly standard exploration approach. There was an earlier survey, mag survey flown, and then we completed a more detailed survey in 2012 with a helicopter-borne survey on very close spaced lines and a very close drape, and this gave us a much better picture of the Huhu contractor work. So this is the majority of the southern end of the contractor work, and it outlined quite an interesting volcanic center shown here in this sort of pattern. That's this pattern here is about 12 kilometers by maybe 6-7 kilometers wide, and has some radial features away from this. So we actually interpret this as sort of central volcanic cone to the complex. And then quite a complex mag pattern with a lot of mag highs and a series of lows around this area. We completed extensive soil surveys shown here in this grid. We found some coincident copper, moly, and gold anomalies. They're actually strongest up in this north area, but we were actually restricted from working up in this area because of some community issues, perhaps luckily in retrospect, I suppose. But the first area we really drilled was this multi-element anomaly with copper, gold, and moly in this area here we called Humpulao East. And in fact, the first hole here intersected nearly 400 meters of 0.45 copper and nearly 0.3 grams per ton gold at 138 meters downhole. And we drilled off a small resource here with about 21 holes over the next period of a couple of years. You know, and Humpulao East, to be honest, was absolutely typical of what we expected to find in this lithocap environment. It was slightly below the lithocap, which is shown up here in this sort of more yellowish colors with a lot of advanced argillic alteration. And essentially it's a series of vertically extensive multi-phase dioritic stocks with biotite magnetite alteration and a quartz vein stockwork, with the better mineralization being concentrated in an early porphyry. And then this early porphyry is cut out by several intermineral porphyries, an earlier one and then a much later one that's very low grade. So we had quite a lot of good grade at the top of the system, but it actually diminished in depth. It's actually cut here by a series of diatremes. This is a diatreme with a lot of quartz, buggy residual quartz fragments, which looks actually quite like the one in Onto, and this is another later diatreme. And it's the top part of the system was overprinted by essentially a low temperature argillic alteration for the top 200 meters. So it's essentially just on the edge of the lithocap, and it's a magnetic target that we drilled. They're associated with the geochem. And this is sort of what we were targeting on the edges and just below the lithocap environment. After that discovery here in Sumbawa East, we underwent a bit of reassessment of the soil geochemistry, and I think we decided that we'd target some of these lower grade anomalies, so you know, less intense anomalies, but areas in this area to the south, which is largely lithocap, and we expected obviously the anomalies to be of a lesser extent here, whereas this northern area is essentially where the lithocap has been eroded, and the anomalies are much greater, reflecting mineralization closest to the surface. After Sumbawa East, we essentially moved down to the southwest, drilling about 800-meter holes. We discovered some mineralization in Sorihui, generally just below the lithocap, so the lithocap was largely absent. In hole 33, there was much thicker advanced argillic alteration with quartz dickite and some locally interesting copper and gold grades. And then finally we targeted some drilling in a little further to the southwest based on some increasing amount of advanced argillic alteration and some small phreatic breccias on surface with some copper. And this ended up being the discovery hole 34, and then the outline of the Onto deposit here is shown in this orange circle. So this is onto the discovery part of the program. So the shots that I'll show now will be in a much smaller area within the overall contract work here, so just within this purple rectangle. As I mentioned, the first hole, discovery hole, was really targeted on a weak mag feature and some weak geochemistry with some quite low values in copper and copper only in this area, and some phreatic breccias that seem to have some fragments of mineralization in them. We intersected nearly 400 meters of relatively unaltered andesite, hornblende andesite, and then about 100 meters of quartz dickite kaolinite, and then an 80-meter thick buggy residual quartz horizon with very strong silicification. And then only below that silicification did the mineralization start sharply and continued to the end of the hole. And we had an intersection of nearly 300 meters of 1% copper and over a gram per ton gold. And all this copper was covalite, and it all occurred within advanced argillic alteration. So the first time we'd seen this style on the project, and certainly not what we expected to see. We expected to see something a bit more like Sumbawa East. The next hole, 35, was drilled the opposite way and was similar, and 36 seemed to essentially drill over the top of mineralization and then actually drilled out of advanced argillic alteration and went into some sericitic and potassic alteration. But the real breakthrough hole was this near vertical hole, 37, that essentially was drilled for about 1.5 kilometers depth and intersected nearly a kilometer of 1.26% copper and 0.7 grams per ton gold from nearly 500 meters down to essentially to the end of the hole. And this was really the hole that showed the full vertical extent of mineralization here. Now, many of us working on it in a celebratory mood at this time, of course, but some skeptics pointed out that we could have still drilled down a narrow structure that connected this mineralization in 34 and 35 with 37, and it was just a narrow northwest trending high-grade structure of some kind. But this is what we sort of found in this two early holes. This is an early cross-section showing the first four holes. This would be 34 here, 35, and then this is the top part of 37, this near vertical hole in this area. What looked like bornite had a bright blue streak and turned out to be covalite, and this was essentially the copper-bearing mineral that we saw. The covalite shown here in this sort of darker colors is intergrown with a lot of alunite and is wholly contained within in advanced argillic alteration. And then at the bottom of the hole, we got some very intense alteration with this buggy quartz texture infilled with covalite and pyrite, and in this case still preserving what we even identified them as a quartz vein stockwork, probably part of a more classic porphyry system. And this is largely an alteration section. As you can see, we had unaltered andesites, as I said, nearly 400 meters of unaltered andesites, some quartz porphyrite plus minus alunite, a small narrow quartz alunite zone, and then this very distinctive silicic zone here shown in blue, and then back into more quartz alunite. And this is actually turned out to be a very typical section that we haven't really changed that much since. with a lot more work, we identified that there was a sequence of sediments in here, as I'll show you, and then this lower part is all entirely within a polymictic breccia that we later interpreted as a diatreme breccia. And then luckily in hole 34, we just clipped the part of an intrusion, even though we didn't really recognize it at the time, because essentially recognizing the original rock types through this alteration was exceptionally difficult. And then nearly a year after the initial discovery in 34, we drilled these two holes to the north and south, 500 meters northwest of the good hole in 37. And these both returned similar grades to hole 37. And for the first time really showed the lateral extent of mineralization with a sort of at least 700 meters wide and a northeast-southwest trend. And then this is the drilling to essentially the end of 2019. We drilled 55 holes, but really only 41 of them, if you exclude geotechnical and hydrogeology holes and some redrills, etc., etc. But what we really quickly defined in this drill out program was an area here about 1.5 kilometers long by about a kilometer wide, extending to at least a kilometer in depth. And you can see that it's closed off pretty effectively in the southeast and also on the north side here and on the northwest side, but it's essentially still pretty relatively open on the southwest side. And there's a lot of infill drilling to be done on the southeast portion, although some of that has been done since that time. Nearly 2/3 of the holes shown here in these bold colors have intersections greater than 750 meters at between 0.7 copper and 1.3 copper. And I just point out some of the better ones here in the red rectangles. 37 I already described, nearly a kilometer of 1.3 copper. This other central hole here with over a kilometer of 1% copper and 0.5 grams per ton gold. Also draw your attention to some high-grade intersections here outlined in this yellow color, 24 meters of nearly 7%, 16 meters of 12%. These all occur in what we call the upper Onto zone, which is in this northwest portion here, where a later fault probably allowed some of the system to bleed up to a higher level. And this is what we call the upper Onto zone. It's not actually included in the current resource because it hasn't really been targeted in drilling to this stage. Quickly onto the resources. I'll just skip to the highlighted part here. The current resource for Onto is 1.7 billion tons at 0.89 copper and 0.49 grams per ton gold. Has relatively low arsenic for this style of system with only 350 ppm. A lot of these systems with this style of overprint are dominated by energite, which this one is not. It's dominated by coverlite. And it contains nearly over 15 million tons of contained copper and over 27 million ounces of contained gold. I should point out that this resource, the way Valley calculate things, this is only the resource that falls within two quite well-defined block cave lifts. And so all the resource outside that, even though it's been drilled on between 200 and 400 meter centers, was designated as an exploration target. So in addition to this resource, there's some additional tonnages between 600 million and 1.7 billion tons at between 0.4 and 0.7 copper and 0.2 and 0.3 grams per ton gold. Just looking at the grade a little more, this is an oblique long section, essentially looking to the southwest, but essentially up the main axis of the mineralization, as defined by those 41 holes. You can see essentially this doesn't show the very top of the deposit, but essentially very barren rocks in the upper portion. The upper Onto I already described as just a high-grade lens higher up than most of the deposit. And then defined here in cyan is the 0.2% copper shell and the 0.3% copper shell in red colors. The remarkable thing I think about Onto is the way the mineralization starts so consistently around sea level here. And then once you're in these grade shells, particularly in this 0.3 grade shell, you can see that the grades are very consistent and very uniform, and there are essentially no barren rock types within this area, which we attribute to remobilization and redistribution of the copper, and to less extent the gold, into all the rock types, including some late porphyry phases that would have originally had pretty low grades. So the high sulphidation vent appears to have added copper and smoothed out the original grade variation within the deposit. It's also interesting to note that many of the holes end in high-grade mineralization, so there's certainly a lot of potential at depth in this deposit. We haven't really drilled below about the about 1,000-meter RL level, so 1,000 meters below sea level, because most of the holes terminated at 1,500 meters. Just to quickly put the Onto discovery into a more economic context, this is a grade tonnage curve for copper discoveries, both brownfields and greenfields in the past 30 years, with curves for contained copper at 1, 3, and 5 million tons shown here. Now, this is actually a figure from 2010, but I added the 4 major discoveries since then that greater than 5 million tons in these more blue colors. As you can see, Onto falls an exceptionally good company. It's certainly in the top 20 in terms of contained copper, and close in size and grade to Ogotoyo, Resolution, Sulfato. So the only ones that have similar high grades. So this is about this 1.7 billion tons at just under % copper. As I mentioned, there's a large exploration target that so this star will probably move over in this direction as we complete the drill out. If you compare Onto to producing copper mines, it would certainly be in the top 20, and actually in the top 5 in terms of contained gold. If you look at copper gold porphyries, because it contains nearly 27 million ounces of gold, that's about 840 tons of gold. So getting to the good bit now, getting to the geology. This is a longitudinal section from northwest to southeast, showing the main rock types. Essentially up the long axis of mineralization. And again, this dashed blue line is in this case is the 0.2 copper shell. The oldest rocks are a series of andesites shown here in the dark green color. This is then cut by a polymictic breccia shown here in the light blue that we interpret as forming in a diatreme complex. And it's got an outer tuff ring shown here in pink that extends somewhere away from the vent. It's then capped by a series of sediments up to 100 meters thick in some cases that we think developed in a mar complex on top of this diatreme. And the central part of the diatreme, as I said, shown in blue, is intruded by a series of porphyries, high-level porphyry stocks, from an early porphyry in red to an early intermineral shown in pink to a late intermineral shown in the orange color, and various dikes of this plate in the mineral intrusion higher up in the sequence. And then again, the dashed line is the 0.2, and you can see the mineralization is clearly linked to the top of these porphyries and extends over into the overlying polymictic wall rock. This is the same section just for alteration. You can see that the capping andesites are essentially largely unaltered to illite smectite alteration, shown here in this olive color. And then away from the deposit, it's sort of more regional, this illite smectite grades down into chloritic and then into chloride epidote alteration. And these are seen as regional alterations. The advanced argillic alteration, which the rest of the colors overprints this regional alteration and goes down from a quartz kaolinite dickite here, shown in orange, down through 2 distinct layers of buggy quartz. The upper one being a lot more discontinuous, shown in blue, and extending up into Wadabur, that area I showed where you can see a little bit of it on surface. And the very prominent silicic horizon, which is a silicified buggy quartz horizon, which extends over the whole deposit area and was a very useful marker during the drilling. And then this is underlaid by quartz alunite in pink, quartz prophyllite in this brown colors, and then this reddish color is quartz diaspore prophyllite. And then this trends down in depth to some porphyry-related alterations, which we've linked here. They're usually chlorite sericite overprinting potassic in the central part of the system. Again, looking at lithology in the south-north section, it's similar to the longitudinal, with a clear relationship of the grade to the top of the porphyry systems, and with the higher grades concentrated in the early porphyry, and extending, only up 100 to 200 meters away from these stocks. And again, generally topping out quite sharply about sea level in this case. In general, you can see most of the holes terminated about 1,000 meters below sea level, but we recently, last year, drilled a deep hole down to 22 kilometers and 50 meters. So 2042 meters, and this hole intersected 1.6 kilometers of 1% copper and 0.4 grams per ton gold, including a high-grade intersection in this area in this early porphyry of 100 meters of 6% copper and 1.1 grams per ton gold. So, you know, I think we haven't drilled many. Well, we've only drilled this one deep hole at this time, but there's clearly potential for this mineralization to extend below the current resource. This is the same section for alteration, again, rapidly starting at sea level, and 90% of the mineralization is contained within quartz alunite, quartz porphyry, and quartz diaspore porphyry alteration, with only a very small percentage of the mineralization contained within relic potassic, as shown in this hole. This is the potassic and chloritic alteration. So, and usually right at the margins of the system, or in some cases right at the base of the advanced argillic alteration. And it's worth just you know, mentioning the intensity of this advanced argillic alteration. This is probably one of the, you know, example from onto of a least altered sample. So this is an example of the late intermineral porphyry, where we can still see porphyritic textures, original plagioclases. But even in this sample, which is, as I said, quite unusually well preserved, you can see that the rock is made up of sulfur, silica, aluminum, and iron, reflecting pyrite, and then some potassium reflecting the alunite. And a SWIR analysis indicates this is all porphyrite and alunite, and we did some photography on this sample, and it's essentially quartz, porphyrite, pyrite, diaspore, alunite with some zunite and quite a lot of rutile. So even where even where we can recognize rocks, the alteration intensity is very intense, and in most cases, recognizing rocks is exceptionally difficult. So getting so in the timing of mineralization, we think this is the earliest style of mineralization in Onto. It's potassic and chloritic with some local phyllic alteration, magnetite stringers, with some A and B vein quartz stockworks, and these tend to be quite gold rich. You can see a lot of chalcopyrite and pyrite, and in many cases in the high grade zones, you can actually see bornite included in these veins. This is actually a very small part of the resource and occurs right on the edges sometimes, and also right at the end of some of the deeper holes. And it's got slightly different metallurgy and better recovery of the gold in many cases. So we think a large proportion of the mineralization probably came in at this stage, although there's very little of this style of mineralization remaining. The remarkable step in Onto is how this typical porphyry style mineralization is that, you know, with bornite and chalcopyrite pyrite is associated with magnetite and quartz veins, is transformed or perhaps progresses into high sulphidation epithermal style mineralization dominated by covellite and pyrite. So if we look at what happens to a piece of this potassic alteration, like I showed you in the last slide, we can see it transformed into this case quartz alunite alteration. You can still see the relic quartz veins, and all the magnetite is largely altered to hematite and or removed. You can see it progressing into much stronger quartz alunite alteration with, again, the veinlets preserved, and going down into areas where it's very intense quartz porphyry alteration. But interestingly, in all these photographs, the grade doesn't really change that much during this process. And in actual fact, it usually increases slightly as you go into these advanced argillic alteration types. And the most intense type of alteration is this buggy residual quartz, where essentially most of the elements and minerals are stripped out of this rock, and you're left with the residual quartz, and then in this case, this residual mesh or network of the original quartz veins. Within the porphyry hosted mineralization, particularly the early porphyry, you see some much higher grades, as I described in one of the holes, with, you know, grades greater than 10% copper and 2 to 5 grams per ton gold. And this, we think this is essentially the high sulphidation assemblage replacing the original sulfides, which would have been chalcopyrite and or bornite. And sometimes the grades of copper in these very intense quartz stockworks are quite high. So it may be replacing mineralization that was already quite high grade. But then there's certainly a later event. In this case, as I mentioned, the late advanced argillic alteration is typified here by these a lot of interstitial space generated when everything was stripped out of the rocks, and you're left with essentially this mesh of quartz vein stockworks. And it's then this buggy space in between the veins. It's filled in with in this case by bornite, in this case by coverlite, but also sometimes by pyrite and native sulfur. And this results in a serious upgrade. So you've not got not only the original fairly high grades probably in this material, but then you've also increased the grade during this process. This is a similar photograph showing the mineralization process that takes place in the polymictic breccias above the porphyry intrusions. The fragments in the original polymictic breccia here are replaced by quartz alunite porphyrite, and then with more intense alteration, you actually remove those that alunite and porphyrite and leave these bugs and then a silicious matrix. And then these bugs are filled in by actually usually in the order of pyrite, and if not pyrite, then coverlite, and then if neither of those fill it, actually native sulfur. And this leads to, again, some very high-grade portions within the polymictic breccia with good intervals grading 5% copper and over 1.5 grams gold. There's a few other shots showing this typical placement of mineralization or infilling of bugs by coverlite and pyrite. In this case, a sort of geopetal structure with pyrite on the top. Here, a replacement of all the bug space with coverlite and native sulfur. And you see quite delicate intergrowths of in this case with coverlite, overgrown by alunite, intergrown with alunite, and then overgrown by native sulfur, suggesting quite low temperatures for some of this mineralization and an association with some of these advanced argillic alteration minerals. And then the latest stages are a fracturing event, open space filling, and formation of the pyrite coverlite veins, occasionally up to about 0.5 meters thick, wide. And this particularly in the polymictic breccia and the late intermineral porphyry. And then, as I mentioned, the outcome of this is that the grade is enhanced during this process of forming these veins and these late disseminations in the filling the interstitial space and bugs within the altered rock. And as I mentioned, the grade tends to become more homogenized in the late intermineral intrusion, for instance, which we think originally had quite a low grade, less than 0.2% copper probably, has had its grade increased by this late overprint. Just looking quickly at the timing of alteration and mineralization in Onto. First point would be that Onto is by far the youngest known major porphyry in the world. It probably formed at about 400,000 years ago. So for you guys working in the Archean, this will be a bit of a strange concept. No millions of years, just 400,000 years. So it's an order of magnitude younger than El Teniente and Grasberg, and only really Octedi, which formed at about 1.3 million, is sort of close in age. These three columns show the age and eras on the. This is the capping andesite. The yellow is the early porphyry, and then the red column is the age dating from rhenium osmium on molybdenum, both from B veins in the porphyry part of the system and moly associated with a high sulphidation style mineralization high up in the system. And these are all in a narrow range at around 400,000 years. You can see, interestingly, from these alunite crystallization age dates, that it seems like the alunite and therefore the advanced argillic alteration started forming probably just after the major diatreme event and overlapped with the porphyry event here, and then extended to younger ages and overlaps with the mineralization. And then when we dated alunites that are actually intimately associated with coverlite, i.e. as an overgrown or occurring in close contact, these are generally younger age, overlapping with the rhenium osmium ages, but extending essentially to the present day, in this case, 38,000 years ago. So exceptionally young, and not a lot of space for later intrusions, and we haven't really well dated a lot of these intrusions yet because they're so young. They're very difficult to date, but there's probably a lot more information in terms of the age dating on the early porphyry and then the series of intermineral porphyry within this sort of range. These are also relatively maximum ages because they may include inherited zircons or zircons that form within the magma chamber rather than crystallization. I'm just going to take you now through a quick series of cartoons just to quickly outline how we think this deposit formed. The earliest part of the sequence of these early andesites, which based on zircons we took from regional stream sediment samples, we think formed from about 5 million to perhaps 1 million years ago. They've got interflow horizons and in some cases some bright red cherts and a lot of hyaloclastic textures, suggesting that the early part of this sequence was probably submarine or at least subaqueous. We think it then became emergent with mixed massive plagiapheric and vesicular basalts about the same time. And then we think there was actually some early porphyry event during this stage, you know, from around 1 million to maybe 800,000. And we know this because the diatreme breccia that forms directly after this contains veined porphyry fragments here, shown in here, and buggy residual quartz fragments typical of advanced argillic alteration sections. Contains both of that. So we think there was some early porphyry development and some early advanced argillic development as well. And we have some support for this, and the provisional dating we did on Humpulau East suggested that that intrusion is about 0.8 or 800,000 years old. The next major event was this major polymictic breccia that formed within the diatreme and then formed a tuff ring around it. Very variable clasts, lots of sediments, lots of rounded clasts, lots of altered clasts, lots of buggy residual quartz clasts, and in some cases a lot of a small amount of primary clasts, which juvenile clasts, which indicate the magmatic component of this phreatic magmatic eruption. And this occurred sometime before 840,000 years. This was then capped by a series of sediments, up to 100 meters of sediments and associated volcanoclastics, quite well-bedded sediments, quite a lot of accretion of papillae, very typical of this section, and then quite a lot of bombs that cause chaotic and contorted bedding in the sediments. So a quiescent environment, but still fairly active. Again, I draw your attention to the age, around sometime around 800,000 years, and it's interesting that we know that there were some early hominids in this area that inhabited these and the surrounding islands and flores from about 1 million years ago to maybe 50,000 years ago. And they may have wandered around this area, maybe steaming lakes, maybe cooked a couple of chickens or something, and perhaps witnessed a porphyry deposit forming about 1 kilometer below. But interesting in that it's such a young deposit that we may well have witnessed it to some degree. As I mentioned from the age dating, we think after this system was capped by this large unaltered hornblende andesite, there was some development of advanced argillic alteration, probably in the diatreme at this stage, that predates the porphyry intrusion based on the age dating and the relationships we see. And then at sometime less than 680,000 years ago, we intruded a series of intrusions, an early mineral porphyry, which is characterized by intense A-B vein stockworks in the top part, and a lot of the very wormy Gusano type veins, indicative of the high temperature carapace on top. It's intruded by an early intermineral porphyry, which is characterized by less A veins and magnetite veins, but still a well-developed B vein stockworks. And both of these developed this as essentially a quartz vein stockwork in the upper portions. And then this is intruded by a late intermineral porphyry, which is generally lacks major veins. It has small number of quartz veins, maybe 5 or 6 per 5 kilometer interval, and some B veins, but generally lacks the earlier high intensity veining. At this stage, we think the advanced argillic alteration extends down into the system and it occurs down to at least 1.5 kilometers in the system, and this is typical with this quartz propylite alunite alteration, sometimes containing zunite and topaz and other high temperature minerals like diaspore. I think there's then sort of lower temperature quartz alunite development, and some of this particularly probably occurred at the paleo water table and developing of this very silicic horizon, which we think silicification on top of buggy quartz. And a lot of this is concentrated close to the deposit, close to this probably original paleo water table, and then extends as roots down into the deposit. And actually controls this quartz alunite is one of the major controls on some of the better grade in the deposit. So this is the outcome of these processes. This is the 0.3 shells, approximately shown in the red outline. Essentially green shows this essentially well-developed quartz vein stockwork, typical of typical of any porphyry style system. And then the more remarkable part is this advanced argillic alteration, which completely overprints this system down to essentially the limits of current drilling. And then all mineralization is covellite, and then all exceptionally young, probably forming about in the last half million years. So I'll just leave you with some key observations. As I mentioned, extremely young. The advanced argillic alteration extends down at least 1.5 kilometers and is exceptionally thick, and contains or hosts 90% of the current resource or the current mineralization. And there's quite a lot of evidence that this advanced argillic alteration was quite early and seems to predate the intrusions in many cases. The high sulphidation overprint is complete, and the system is totally coverlite dominated. There are many examples of porphyry systems with some high sulphidation overprint or some lithocap development, but none on the scale of Onto, where essentially everything's been seen this late overprint. Having said that, still 60% of the resource is within the host intrusion and doesn't really extend more than 200 meters away from them. And in fact, we drilled some holes on the southeast side and on the north side where we hit thick sequences of advanced argillic alteration, you know, over 1 kilometer thick in some cases, without mineralization, where we didn't hit any of the intrusions. So there's certainly a control by the intrusions. And most mineralization, even though it may have come in quite early with these porphyry stocks, has been precipitated at fairly low temperatures, probably less than 200 degrees, as it seems to in most cases post-date the buggy quartz development. And then, you know, there's no indication really of a late stereosite stable fluid to mineralize the lithocap, which is you know, one of the current models for how these things are mineralized. So key questions might be, did the porphyry stocks intrude their own lithocap? And this was probably the cause of the very high sulphidation states, as there was no buffering capacity in the host rocks, probably even during the intrusion of the stocks. And then the other key question is, did the vapor causing the advanced argillic alteration bring in additional copper and gold? I mean, we generally know that it brought in arsenic and antimony and various other elements, but did it bring in copper and gold as well, or did it just remobilize that from existing mineralization that was brought into the system earlier? Or as is postulated in many current models, did a later single phase fluid precipitate mineralization higher in the lithocap as the system went to greater depths? So I'll just leave you with this very large grassroots discovery, and it's pretty much a sort of essentially a hybrid porphyry high sulphidation epithermal discovery. Very large resource containing 15 million tons of contained copper and over 27 million ounces per ton gold, and already growing, and has grown in the drilling since that time. Copper is occurring as coverlite, reflecting these very high sulphidation conditions as fluids evolved into advanced argillic alteration. And then, as I mentioned, one of the key aspects is it's extremely young and formed in the last 500,000 years. And I think I'll call it quits there. Thank you very much.